Okay, let's have a go at tackling the following problem. The problem definition is here from line 1 to 5, pasted onto the code as a comment, and it's about finding the sum of the first 20 terms of the series shown on line number 2. So if you take a look at it, there's a bunch of ratios where the numerator goes from 1, 2, 3, 4, 5, 6, so on, increases by 1, whereas the denominator starts with 30 and decrease by 1, and if you were to sum up to 20 terms, the answer is 13.0466. That's what we are trying to program. So the first thing is I would like to add a loop, for loop, like this. So we'll start with the term 1, and we will increase the term to less than equal to 20 up to the 20 terms, and we will let the loop run one term at a time. And if I were to write a system out print line and get the term to print, and let's run it, and you will see that what we have is the flow of the for loop starting from 1 ending up to 20. Right? So this is a good starting point. Next, what we will do is right after here, end of line 8, start a variable. I'm going to start a variable of type double, and we will say I'm going to start with the numerator. I'll abbreviate the numerator, I'll call it num, and the denominator will call it denom. So since the numerator here goes from 1, 2, 3, 4, 5 and it matches the term, I can make the numerator equals the term. So both are the same. Let's try to get the denominator. So if we want to get the denominator starting from 30 and go subtract 1 from 30 as the loop goes, as the loop progress. Let's start the denominator here with 1 more than the 30 or 31, and then let's do minus minus denom, which means that it will start with 31, and 31 minus 1 will give you 30, and so on. And let's try to print with, I'm going to add a tab separator and then add the denominator variable in here, and let's run it to see if we have modeled things correctly. Go to run, and if you scroll up to the top, you'll see that the first number is 1 when it is 1, denominator is 30 when it is 2, 29, 3, 28, 4, 27, and that matches, that models the problem definition correctly. I'm going to change this actually from term to numerator. Right, so we have the numerator and the denominator figured out correctly. Next, let's divide these two, numerator and the denominator, and add to a variable called ratio. Let's define the ratio equation as numerator divided by the denominator. Like that. And now let's see the results. Let's first add a tab separator and then the variable ratio. And let's see if we were to run it, what we will get. And if you scroll to the top again, all I've done is add the third variable to the system out print line, first the numerator, denominator, and the third one, numerator divided by the denominator, gives us the ratio, and it goes, like you can see, from term 1 to term 20, all the ratios. Next, let's add another variable to sum things up, and we will equate to 0 because that's a starting place for the sum. So we'll, after line number 13 on 14, we will add the equation sum equals itself, sum plus the ratio. And that's why when you have a sum on the right hand side of the equation, that's why we are equating it to 0 to start with. So you start from 0 and you keep on adding the ratio to it, and then the sum gets carried over from there. So let's add another line separator here to the end of ratio as follows, and then I'm going to add the variable sum, and let's run it. And if you do it, let's see the results. From each term, when the ratio is 0.033, the sum is that. When for the second term, it's 0.06, 0.03 and 06 is added to give the sum after two terms to 0.103, 0.1022, and so on. And if you take a look at the last term, and that the sum is 13.0466, and we've certainly achieved the answer.